Hello guys, this is Professor AutoCAD here. Welcome back. Well, after I told my friends that I've started a YouTube channel, they're all crazy and saying, "Oh, go talk about quantum physics lah, you'll definitely do better than our physics teacher back in high school." Well, making science videos is me trying to explain something difficult in an easier way, like telling you 1 is before 2 and 2 is before 3 and you just have to know it. The real deep things inside, that would be the jobs for scientists and researchers. Just like how I explained the marriage. It's me telling you that 4 is before 5 and 3 is before 4. Then you just have to match it up with the previous stuffs like 1 and 2 and 3. But quantum physics, it's that 3 comes after 1 and 5 comes after 3, but you cannot take 2 and 4. It's confused. Then you definitely ask, why? Why is it like that? It's so confusing. That's the problem. Even scientists and researchers are asking the why. Worst case scenario is when you're listening to lectures in universities talking about quantum theorem. Some professors, I'm definitely not saying all of them, just some of them, they would just tell you to just shut up and calculate. Like, no questions are allowed. Hiya. Yeah, quantum theory. This definitely requires more cognitive changes and reserves of mathematical knowledge. Well, there are two things that we would immediately think of when we talk about fancy physics. One is relativity, the other is quantum theory. There are definitely debates among the topic in science, but the debate in relativity among scientists would basically be none. The debate is usually among the scientists and cranks. But the quantum theory, that would be a totally different story. Even scientists would fight against that. Like, some of you might know that Einstein did not approve the quantum theory even to his death. So, yeah, that's quite tricky. But to satisfy everyone's curiosity, I'm here. I'll try my best to talk about quantum theory. The quantum theory consists of a lot of things. The quantum physics, the quantum fields, blah, blah, blah. But I know what you guys really want to know. You guys want to know what is quantum, what is the spin, what does it have to do with this cute little cat, what is quantum entanglement, what is a quantum computer. These interesting questions. Well, I'll start from the history of the development of quantum. I'll try not to talk about the calculations, we're just here to listen to stories. So these quantum related videos would be called the Quantum Story Club under the Science and Wonders series. That's the beauty of science videos. General science is just like this. The scattered knowledge we found online will just gather up together after we listen to the stories, and you'll discover some more interesting stuffs. For example, Wilhelm Röntgen, this guy, the year he discovered X-ray. Einstein was 16, probably self-learning calculus. Bohr, 6 years younger than Einstein. 10 years old. Okay, let's get back to the real topic. So, normally, when introducing relativity and quantum theory, we would mention about the two problems for 20th century physics, so-called the two clouds. At the year 1900, the Irish physicist Kelvin had a lecture at the Royal Institute of Great Britain. Well, Kelvin, father of thermodynamics. This word is also one of the 7 base units of the International System of Units, SI units, specifically for temperature, not Celsius, not Fahrenheit, none, just Kelvin. Well, his name is actually not called Kelvin, it's William Thomson. Kelvin is the river next to his laboratory, so in memory of William Thomson, people call him Baron Kelvin. Baron is a peerage. The descending order is Duke, Marquess, Earl or Count, Viscount, and Baron. Even though William Thomson is just a Baron, this does not affect his nobility. At the year 1900, our old Kelvin, at the age of 76, mentioned about the two clouds. The first one is the relative motion of the ether with respect to massive objects. Well, ether is a theoretical universal substance believed during the 19th century to act as the medium for transmission of electromagnetic waves, while the other cloud is the Maxwell-Boltzmann's theorem on the equipartition of energy. It's okay if you don't understand anything of what I said just now, neither did I back in high school. But no problem. You've probably heard of the respective experiments. The first experiment is the Michelson-Morley experiment, proving the speed of light is actually a constant. The second cloud matches up with the black body radiation. It was definitely not expected that soon after, these two clouds would become the two great giant trees supporting the world of modern physics, which is relativity and the quantum theory that we're going to be talking about. But today I'm not going to be talking about the black body radiation. It'll be saved up for the future. So, before the year 1900, there are 4 things that classical physics cannot solve. First one is the hydrogen spectral series. Second, the photoelectrical effect. Third, the black body radiation. And fourth, the stability of atoms. These are the unsolved mysteries back then, and we'll look into them one by one. Okay, the first one, the pattern in the hydrogen spectral series. Well, physicists and scientists aren't omniscients, so the discovery of the patterns by curiosity and by chance, especially experiments. Talking about experiments, these things back then is just taking a normal mirror or a piece of glass and observe the light patterns. But Isaac Newton, this guy, his curiosity cannot be just satisfied by these simple little stuffs. A plain piece of glass is just too basic. What will happen if light passes through a triangular prism? Newton discovered that the beam of white light would become a row of colored lights. It's related to the wavelength and refraction theory we've mentioned in our first video. And Newton called this the light spectrum, which in our modern day it's called the visible light spectrum, because we know that there are other X-rays, gamma rays, ultraviolet, infrared, microwave, radio waves that cannot be observed by our naked eyes. Some further experiments would be burning stuffs. Well, kids, never ever burn stuffs at home, or alone, or without the supervision of adults. This is a literal warning. Scientists would observe what happened after they burned stuffs. The physicists found out that if they excite an element in a certain way, for example, burning them, then allow the light to pass through a triangular prism, then you'll see the light spectrum of each element would be unique and different. It's quite beautiful, to be honest. So, burning element and observing the light spectrum has always been quite a fun experiment for scientists back then. But no one knew why would this happen, what's the pattern behind. They know basically nothing. However, scientists can determine whether the object they burn contains a certain element or not. For example, maybe I want to burn an object, then I grind it into powder, burn it, observe the light spectrum, compare with my known list of light spectrum for each element, and found out that, oh, there's carbon, there's oxygen, there's other elements inside, and that's it. Well, scientists knew that hydrogen was the most basic element, 1 proton, 1 electron, that's it. So they decided to play with the easiest one. But the light spectrum of hydrogen is quite different from the one we see from white light. Well, you've probably seen the light spectrum of white light, it's just rainbow. But the light spectrum for hydrogen is different. There's colors in some areas, there's no colors in other areas, and the spacing between 2 lines are very different. So at first glance, there's no pattern, there's no way to begin, there's no way to start. The only thing physicists could do is to calculate the wavelength of each line, but the pattern within them is just visible confusion. Until 1884, a genius, you can say, published the formula for the pattern. And his name is... No, not John Cena. His name is Johan Jakob Balma. Was he famous? No, he wasn't. He wasn't even a physicist before publishing the Balma series. He was just a high school maths teacher, someone we really hate. Balma, born in Lausanne, Switzerland. For those who have been to Switzerland, at least I haven't, might know that the winter there is long and cold. So at the end of winter, people would burn a snowman figure called Boog, which symbolizes the winter. The burning of the boog serves to drive out the winter and herald the spring. But in winter, no one would want to go outside. It's just cold and freezing. Researchers would just stay at home, be a couch potato, and do their own research. And Balma, he has been interested in maths ever since a very young age and is very sensitive to numbers. Like, a shepherd is tending a flock of sheep, and Balma just needs to have a glance and know how many sheep are there, and immediately telling you that this number is the product of which two prime number, or the product of which two square root number. God, is he Rain Man or what? 1884, Balma, age 59. He's a maths teacher in the University of Basel, and he was complaining with his colleague one day. This colleague, a physics professor in the university, was doing research on the hydrogen spectral series. Balma's complaint was somewhat like, "Oh, I've solved all difficult questions in the world. Nothing can really stop me. So lonesome." So his colleague was like, "Okay, then do this," giving him the hydrogen spectrum series and the wavelength values. 2 weeks later, yes, just 2 weeks, Balma gave us this formula, where the error between the calculated wavelength and the observed wavelength is just less than 1 in 40,000. What the hell can I say? Bravo. That's it. So, in memory of Balma's great act, a crater on the moon is named after him. The only bad thing is that Balma was just responsible for writing out the formula, but he could not really give any explanation to that. So, why does Balma's series look like this? No one knew back then. That year, 1884, Einstein was just 5 years old, and Bohr was probably just a little zygote, not even being given birth. Great! I guess that's all for today. If you like my channel, please accent the like button, follow my Instagram account, which is still empty for now, subscribe and turn on the notification bell, and I'll see your beautiful face next time. Bye!